Imagine floating in the deepest, darkest ocean you can conceive, utterly alone, far from home. This is the reality for the Voyager spacecraft, humanity's most distant explorers. For decades, they've sailed past giant planets, sending back snapshots of our solar system's wonders. Now, they've crossed the final frontier, entering the vast, uncharted space between the stars. Out here, they made a discovery that reshaped our understanding of the cosmos. These probes, no bigger than a car, are our silent ambassadors, carrying the sights and sounds of Earth. Their mission to read the universe's story and send it home. As they ventured further, the sun's influence faded, replaced by the subtle whispers of the galaxy. The data they sent revealed a boundary far more complex than anyone imagined, a turbulent region where the sun's breath meets the gales of interstellar space. Here, Voyager detected a wall. Not solid, but a vast, invisible barrier of superheated gas. This discovery forced us to rethink what defines a solar system. Our solar system isn't a tidy collection of planets, but a dynamic bubble constantly interacting with the galaxy. At its edge, a glowing, superheated frontier reminds us, the more we explore, the more wonders we find. The story begins in 1977, when NASA launched Voyager 2 and then Voyager 1, two identical spacecraft on a mission to explore the outer planets. Their timing was perfect. A rare planetary alignment allowed them to slingshot from Jupiter to Saturn, Uranus, and Neptune. Packed with cameras and scientific instruments, they captured breathtaking images and measured magnetic fields and charged particles. After their planetary tour, the Voyagers kept going, on a path out of the solar system. They became humanity's first interstellar probes, tasked with studying the edge of the sun's influence and sampling the space between stars. Today, over 4 decades later, they're still traveling, still sending signals across billions of kilometers. Voyager 1 is now over 24 billion kilometers away, Voyager 2 not far behind. Their signals take nearly a day to reach Earth, making them the most distant human-made objects ever. Their journey is a testament to human curiosity and ingenuity. To understand Voyager's discovery, we need to know about the heliosphere, the vast bubble created by the sun's solar wind. This bubble shields us from harsh cosmic rays, acting as our solar system's protective atmosphere. Without it, Earth would be bombarded by dangerous radiation. The edge of this bubble is called the heliopause, where the solar wind's push is balanced by the pressure of interstellar space. For years, scientists wondered what this boundary would be like, calm or chaotic. As Voyager approached, its instruments detected the solar wind slowing, heating, and piling up against the interstellar medium. This region, called the termination shock, leads to the heliosheath, the final layer before the heliopause. Crossing the heliopause means leaving the sun's domain and entering interstellar space. For Voyager, reaching this boundary was the ultimate goal. Their data revealed a turbulent, dynamic frontier, far from the simple edge we once imagined. The Voyagers became our scouts, mapping the unknown at the edge of everything we know. Their findings redefined our understanding of the solar system's true boundary. In 2018, as Voyager 2 neared the heliopause, its instruments detected a dramatic spike in temperature. The spacecraft had entered a region of hydrogen gas far hotter than expected, a true wall of fire. Years earlier, Voyager 1 hinted at this, but only Voyager 2's working instruments confirmed it directly. The data showed that as the solar wind collides with the interstellar medium, it creates not just a pressure wall, but a thermal one. This wall isn't solid. It's a vast, diffuse region, billions of kilometers thick, with incredibly fast-moving hydrogen atoms. The temperature here reaches up to 50,000 Kelvin, hotter than the sun's surface, yet the gas is so thin you wouldn't feel the heat. This paradox challenged existing models and sent scientists back to the drawing board. The edge of our solar system, once thought cold and empty, is home to a structure hotter than the star that created it. Voyager's discovery revealed a beautiful, unexpected complexity at the solar system's frontier. It's a reminder that even the emptiest spaces are filled with surprises. So, what is this wall of superheated hydrogen? It's the boundary between the sun's bubble, the heliosphere, and the local interstellar medium. The hydrogen wall forms just beyond the heliopause, where our solar system plows through the galaxy's thin gas and dust. Neutral hydrogen from the interstellar medium can cross into the heliosphere, while charged particles are forced to flow around it, creating a cosmic bow wave. The intense heat comes from this compression, like air heating up in a bicycle pump. Complex plasma processes further energize the hydrogen, raising temperatures to extraordinary levels. This wall isn't part of our solar system, but the galaxy's response to our presence. Voyager had to cross the heliosphere, the heliopause, and then this heated region to detect it. The discovery gives us a unique fingerprint of how stars interact with their galactic environment. The hot hydrogen wall tells a story of motion and interaction. Our sun and planets orbit the Milky Way at incredible speed, constantly moving through the interstellar medium. The wall forms as our heliosphere plows through this plasma, compressing and heating it at the boundary. Magnetic fields from both the sun and the galaxy interact, forcing the interstellar plasma to flow around our solar system's bubble. This diversion and compression generate the intense heat Voyager detected. Before Voyager, we only had theories, now we have direct measurements. Studying this wall helps us map our galactic neighborhood and understand the raw material for future stars and planets. It also lets us test models of astrospheres, the bubbles all stars create around themselves. By understanding our own, we gain insight into planetary systems everywhere. The wall proves that nothing in the universe exists in isolation. The discovery of the hydrogen wall has profound implications. It may act as an extra shield, filtering out more galactic cosmic rays before they reach the heliosphere. This two-stage defense could make our solar system even safer for life. The wall's dense plasma and magnetic fields might also affect how low-frequency radio waves travel, something future astronomers must consider. Most intriguingly, if our sun has this protective sheath, other stars likely do too. The strength and temperature of a star's wall could influence how well its planets are shielded from cosmic rays. Some solar systems may be better protected, creating more stable environments for life. When searching for habitable exoplanets, we may need to consider not just the planet, but the protective bubble around the entire system. The hydrogen wall adds a new dimension to our search for life in the universe. It reminds us that the space between stars is alive with structure and influence. Voyager's discovery raises a grand question. Do other stars have similar protective bubbles? The answer is almost certainly yes. Most stars generate stellar winds, creating their own astrospheres. As these stars move through the galaxy, their astrospheres interact with the interstellar medium, just like ours. Detecting these structures is challenging, but astronomers are finding ways, like searching for bow shocks in infrared or ultraviolet light. The Hubble Space Telescope has already glimpsed these features around nearby stars. Studying distant astrospheres could reveal which star systems are best shielded for life. Habitability isn't just about a planet's distance from its star, but also the protection offered by its cosmic bubble. The hydrogen wall gives us a template for understanding these universal phenomena. The Voyager spacecraft are more than scientific instruments, they're cultural ambassadors. Each carries a golden record, a time capsule of Earth's sounds, music, and images, a greeting to any future finders. As Voyager passed through the hydrogen wall, it crossed a final fiery gateway before leaving home. The Golden Record's journey is a powerful metaphor. To reach the unknown, you must pass through a trial that changes you. Voyager's legacy is one of inspiration, pushing boundaries, embracing the unexpected, and revealing the universe's hidden wonders. For nearly half a century, these probes have shown us the beauty and complexity of our solar system and beyond. The discovery of the hydrogen wall redefined our cosmic address. True exploration means finding the unexpected and letting it transform our understanding. Even the emptiest space is alive with drama and discovery. Voyager's story inspires us to keep reaching for the stars,